Welcome once again to the Mad Science Lab. We are so glad you're here. Now, if you look around, you see Jeremy and the boys have all this stuff here, and you're probably going, what in the world is that? Now, if that's what you're asking, I'm thinking, that's a good question. What in the world is that? Well, a few days ago, the Earth started moving around as if we were on one of those giant trampoline things, and it just felt really, really weird. So Jeremy and the boys were saying, Daddy, what is going on? And I told them, it's an earthquake. Now, what in the world is an earthquake? Well, an earthquake is the sudden, rapid movement between two rigid blocks of the Earth. You mean the Earth's made out of blocks? Well, not like you're thinking, okay? Think about this. This movement occurs along a surface between two blocks that are called a fault. Yeah, that word right there. Yeah. The movement releases energy and generates seismic waves. Ooh, that's a big concept. There you go. Another big idea that can be recorded by specialized instruments used by scientists. Now, the point on a fault at which the first movement or the break occurs during an earthquake is called the earthquake's hypocenter. Here, take a look at this picture. yeah, that little point right there that looks like a big ball, that's the hypocenter. And then where it comes up to the surface is called, oh yeah, another word, the epicenter. Well, in the case of a large earthquake, a section of a fault or that block, it could be many miles away from where the hypocenter is. But there's always a point at which this first movement occurs. And the way scientists can tell where this point is they have a grid on the Earth, and they call it longitude and latitude and dips. I know, you're probably thinking, what in the world is he talking about? Don't worry, I'm going to tell you. It's where exactly on the Earth's surface that this epicenter directly above the hypocenter happens. It's usually what you see, when you hear somebody on the news go, there was an earthquake and it occurred at this specific place. They're talking about the epicenter. And that's where the longitude or the lines and the latitude or the lines on the Earth actually tell us exactly where it is. I know that's a lot of information, but don't worry. We're going to have fun with it here. Now, listen to this. I told you about the blocks. We call them tectonic plates. Another word. Yeah, tectonic plates. And they're like big sections of the Earth that kind of fit together like a giant jigsaw puzzle and hold the top of the Earth in place. Okay? The tectonic plates can move around by convection currents or movement underneath them in what's called the Earth's mantle. Here, take a look. If you look at my model right here, this right here would be the surface of the Earth, and you look and see how thin that is. That's what I was thinking too. But this big orange part, that's called the mantle. And then underneath is called the outer core and then the inner core. All of that is a lot of information, but don't worry, we're going to be talking about how earthquakes happen. In the Earth's mantle, the convection currents are generated by changes in temperature and density. The warmer materials in the lower part of the mantle go up, and the cooler ones go back down, just like it does everywhere else. And all that change means there's a lot of movement, and it can affect the tectonic plates. Wow! I know what you're thinking. What in the world does all that mean? Can you show me something to make it make sense? Yes, I can. Check this out. This is what we like to call an egg. And the reason I call it an egg is because that's what it is. Okay, now look at this. If you look at the egg, now I know you've seen an egg before, and you know that inside the egg, there's a shell, and then inside there's that big section that's the white part, and then inside that's a smaller section that's the yellow part. Yep, okay, so watch what happens if I break it. See that? I broke it right there, and you can see all those cracks, but also over here, there's a longer crack, and you can see how that spread apart, and see how that one bulged up there, and that one stayed right there, and then there's another crack here, and it keeps going around and around and around. If this were the epicenter, or the part they talk about on the news of the earthquake, then people could feel it a long, long way away over here, and this tectonic plate, like these two sections here, might be changed just like that is. And that's exactly how an earthquake works. Pretty cool, huh? Well, I can eat the egg, but I can't eat the earthquake. But anyway, that's how it works. Okay, so this is cool. As I push on this, then you can see that another one pops up. So one pops down, the other one pops up. As it moves around, you can see that it cracks more. And that is the same way that the Earth's surface through earthquakes is reforming all the time. And you can see that one side pops up a little bit above the other, and that creates a boundary. Oh, boundaries. Let's talk about that. See, when the tectonic plates move against each other, they create boundaries. So they bump up against each other, or they slide past each other, or one gets on top of the other like that. Hang on, let me show you. I've got a really cool game we can play to show how these boundaries work, okay? And so this is what you need. Okay, so I've got a plate, and I've got some cake icing, and I've got a stick to mix it with, and then I've got some red food coloring because I want it to look like the mantle, and then I've got a cup to mix it in, and then I've got some graham crackers to be my plates, okay? So let's pull this lid off here, and I'm gonna take some icing out, and I'm gonna put it here in my, put it over here so you can see it. I'm gonna put it here in my cup, if it'll go down. Okay, and the reason I'm putting it in my cup first is because I want to make it kind of red or reddish pink so it'll look more like the mantle, okay? So I'm going to put some red food coloring in here, and then we're going to mix this up here like this, and we're going to dump all this out right here onto my tray, and then we're going to spread this out. Okay, so this is going to be like the mantle of the Earth. It's not quite on the Earth's surface, but it's just underneath the surface of the Earth. So there we have the mantle, and I'm going to use these crackers to be my surface of the Earth, or my Earth's crust right here. So if that's a tectonic plate there, and that's a tectonic plate there, now watch what happens when they push together. Oh, you see how that popped up there? That in the middle popped up right there? Yes, okay. Now we're gonna slide them apart. Now watch what happens when they slide next to each other. See, it popped up again. Okay, so we're gonna have another plate here. Now watch what happens when they push together. Oh, look at that. One went up on top of the other one just like that. And you can see part of the mantle came out, and that's right next to it, okay? So the first one, when they passed by each other, like this, when they just passed by each other, that's called a transform boundary. Transform, yeah, there's the word. Transform boundaries are characterized by long faults, or these long lines where they go next to each other. Sometimes they're hundreds of miles in length, and by really shallow earthquakes. Transform boundaries were named for the way that the Earth's crust changes or transforms its relative direction and how fast it moves from one side of the boundary to the other. And the next one, where they bumped up against each other, this one right here, I like to call that a convergent, there you go, convergent boundary. And that's when two tectonic plates move towards each other. And when they collide or bump into each other, the denser one or the thicker one eventually goes down below the other one, okay, into the mantle, and downward convection occurs, okay? So it brought that current down, and that's a process called subduction. And in subduction, this one went down and the other one rose up above, and it also took some of the mantle with it. So you might see that in an earthquake, there might be, just like in a volcano sometimes, even if there's an earthquake, there might be some oozing from the mantle, or even some maybe even a little lava flow, or just a lot of dirt and rock that comes up. One more, and we call that divergent boundaries. Divergent boundaries. Most divergent boundaries are found under the sea, along the seafloor, and they form when the mantle actually pulls apart from each other like that. And when it does, a new formation of an ocean crust is going to happen, because some of that mantle is going to come up to the surface and then start cooling off and create a new landform, but underneath the sea. And so that can happen, and when that happens, then we're going to get shock waves or seismic waves, and we're going to talk about that right now.